Good evening,
Hi
sir.
Lokesh. Good evening. How are you?
Fine, sir.
Right. Okay. Right. Have you solved the questions on the current electricity part? Okay. Let's start now. So here in current electricity, what we discussed till now, series and parallel combination of cell. Okay, na? Using the Kirchhoff's law, how to solve the circuit, right? Use of what? Ammeter and voltmeter. And when we connected the ammeter and voltmeter, one more thing we have learned that voltmeter is what? Connected in parallel to the circuit element, and ammeter is connected what? In series to the circuit. Okay, right? This is what we have discussed till now. Understood? Now, the next part we are going to discuss what is the whenever the current will flow through a resistor, what will happen? There is going to be heat developed in the resistance, isn't it? Heat developed, or you can say that power developed in the resistor. Okay, so learn about what is the power loss in resistor and the bulb. Okay, power generated in a resistor. Okay, so what is the power generated in a resistor? Meaning is what? Like, let's say a battery is there, which is the source of EMF. It has some internal resistance, and now it is connected externally to what? And resist a resistor of resistance R. So what will happen? There is going to be the current flowing in the circuit, right? Battery will discharge, and this is how the current is going to flow in the circuit. So if I calculate the current, what we will get it? EMF divided by total resistance. And if we calculate the total resistance, we are getting a small r plus capital R. Okay. So now if I calculate what is the power developed in a resistor, okay. So power generated in a resistor, generated in a resistor. So what is the power we are going to get it? So that will be voltage across the resistor into current in the resistor. So this is the power formula. Okay, power is how much? Power is equal to voltage into current. But this formula can be converted into some different format. Like what? Like power equal to voltage into current, right? Can I write it? I equal to V by R also. So the power developed in a resistor can be written as V square by R. Okay. And the third one is what? Like this one. Power is there. V can be written as I into R, and another I is there. So what is the power we are getting? I square into R. So now, depending in the question, what is given to us? Like if I know the voltage across the resistor as well as the current in the resistor, then we can use the V into Y. Okay. Or if I only know the voltage across the resistor and the resistance, then we should use it V square by R. Okay. Or if I know the current in the resistor and what is its resistance, then we can use it I square into R. So depending on the question, what is given to us, we should use out of these three any one of the formula. Okay. So this is the power generated in the resistor. Now, from the power, can we calculate what is the heat energy generated in the resistor? So power and energy, what is the relation between them? Power can be written as energy developed per unit time, isn't it? Energy developed per unit time. So energy, if you want to write it, you can write it power into time. The heat energy, okay, heat energy generated in the resistor, generated in the resistor, how much it is going to be? So heat energy, when I'm talking, can I write it? It is going to be power into time. We can write it as what? Power into time. So heat formula, you can write it Vi into T, or V square by R into T, or I square into R into T. So from the power, we can find out energy by what? By multiplying the time in the power equation. Okay, now. So from power, how do we calculate the heat? By multiplying power with what? The time we will get the heat developed. Understood? But here, what I am thinking that power is constant, right? Means the current is constant, voltage is constant, which may not be the case every time, isn't it? Sometime it may be possible that the question will give you the current flowing in the circuit is a variable one. Okay. So if that is the case, then what I should do it? I should first calculate TH equal to VI into dt, and then what we will do it, we will integrate it to get the total heat developed. Understood? So first one we have written for heat when we will apply this one, when current and voltage are what? Constant. Okay, when current and voltage are constant, we should use this formula. And the second one, when we will use it, if current or voltage, if current is variable, the voltage automatically it will become variable. You will see it in the alternating circuit. The voltage and current are what? Variable in nature. So if current or voltage is variable, if current or voltage is variable, then what we should use it? Then we should use it, this integration method, to calculate the power developed or heat developed. Understood? So please tell me, up to this part is clear? Please tell me, clear up to this? Now, the next thing is called the maximum power transfer theorem. Okay. Next thing is called the maximum power transfer theorem. Okay. What is the maximum power transfer theorem? Okay. Maximum power transfer theorem. Okay. So, according to this maximum power transfer theorem, what we are going to learn, that let's say there is an external resistance R here. Okay, and there is a battery of EMF E and internal resistance what? A small r. Maximum power transfer theorem means what? That see, this is the current flowing in this one, and what I am going to do, see, battery EMF we cannot change, and the battery internal resistance, that has some fixed value. So what I am going to do it, I am going to change the resistance value. Okay, And now, after changing the different value of resistance, I will try to find out what is the power developed in this resistance R. Okay, this arrow symbol is the symbol of what? Variable resistance. Okay, so tell me when I will get maximum power passing through the resistor R. If I keep on continuously increasing the value of capital R, this resistance, if I keep on increasing, am I going to keep on increasing the power also? Please tell me. If we keep on increasing the value of R, capital R, which means external resistance, is the power consumption will also keep on increasing? No, it is not going to happen. Okay, so there will be a particular value of this external resistance when the power transfer is going to be what? The maximum. We want to calculate that one. Okay, so now tell me what is the current in the circuit? So can I say current in the circuit is E divided by small r plus capital R? Now if I calculate what is the power in this resistor, what I will do it? I square into R. So I know that E square by small r plus capital R square into R I have done. Now, if you look at this power expression, you will see that in this expression, everything is constant. EMF is constant, internal resistance is constant. And what is changing in the question? In this question, the external resistance R will change. And for different value of capital R, external resistance, you will get different power consumption. Okay? Power consumption or power developed in the resistor. So we want to see what should be the value of capital R so that this power should be maximum. Understood? So that means whenever we want to maximize something, should we do one thing? dp by dr, I should find it first and make that what? 0. Isn't it? If you want anything to become maximum, what is the condition needed? The first derivative of that function should be 0. Second derivative should be what? Negative, right? So let's find out dp by dr and then let's make that equal to 0. That is going to give us the condition required for maximum power transfer through the resistor or transfer to the resistor. If you write it d by dr of E square r by small r plus capital R square. So what are we getting here? Let's make it equal to 0. So you see that if you differentiate it, it will become r plus r whole square to the power 2 again, right? U by V method we are applying. E square is a constant, leave it out. Denominator outside, d by dr of numerator minus numerator outside, d by dr of denominator. So if you simplify it, you will see what you are getting. E square constant, denominator become r plus r to the power 4. Look at the numerator. If you look at the numerator, you will find out it is r plus capital R whole square. D by dr of r is 1 minus r. If you differentiate this one, it will come 2 into a small r plus capital R. And again, you differentiate it using the chain rule. Just one mistake here. It will be d by d capital R. Okay. And again, if you differentiate it, what are you getting? Small r differentiation 0, capital R differentiation 1. This is what we are getting. Okay. Just simplify it and you will see that what we have. E square r plus r to the power 4. Look at the numerator. Are you going to get r plus r common? So what I am left, r plus capital R and minus 2 times of capital R equal to 0. So we are getting capital R equal to small r. What did you learn from this expression? So this expression tells us that maximum power will be transferred through an external resistance when that external resistance become equal to what? The internal resistance. Understood? So when the external resistance becomes equal to internal resistance, what happened? At that resistance value, the maximum power will be transferred through the resistor, external resistance. And if I ask you what is the maximum power, so what is the power expression we have? E squared capital R. What should be capital R? It should be equal to internal resistance. A small r plus capital R is also small r. So we are getting E square by 4R. This is the maximum power consumed in the external resistance. Clear? So if you plot the graph of power consumption in the external resistance and the resistance, you will see this kind of graph will come. Something like this, right? And what is this resistance value? This is the value of external resistance becoming equal to what? The internal resistance. And when that is going to happen, the power consumption is going to be maximum. And what is the maximum value of that power consumption? E squared divided by 4 times of the small r. Clear this one? Please tell me.
Yes, sir.
Please tell me. Clear this one?
Yes, sir.
So this is the condition required for getting the maximum power transferred through a given resistance. Okay. So if you keep it as a variable one, then what will happen? The maximum power transfer through that resistance will be coming when that resistance value becomes equal to what? Internal resistance of the cell. Okay. At that time, the power consumption through that resistance will become maximum. Understood? Now let's discuss few examples now. Okay. Okay. In this example, what is given to us? Okay. In this circuit, this is what given to us, and this is another parallel connection given to us. 10 ohm, 10 ohm, 10 ohm, and this is also 10 ohm given to us. Okay. Battery voltage is how much? 100 volt is given to us in the question. Okay. Clear? Now we have to find power consumption in each of the resistance. Okay. Each of the resistance means what? External resistance. This is R1 external resistance, R2 external resistance, and this R3 is also what? External resistance. Okay, so find power consumption in R1, R2, and R3. What is going to be the power consumption in these three resistance? Let's find out. Okay, very simple values are given. Okay, so what you will do it? Can we calculate first what is going to be the current flowing in these resistance, or what is the voltage across these resistance, isn't it? Because to calculate the power, either I can use it I square R, or we can use it what? V square by R. Okay, so tell me what you want to use it and how much is the answer coming. Please tell everyone. Trying to calculate, use it series parallel kind of circuit question. Okay, now use it them like it's a series and parallel combination. Okay, find out the R equivalent. Okay, find out the current in each of them. Okay, so please tell me how much is this coming.
Mm. Sir, R1 power is 160 volt.
R1 power is how much?
160
What?
watt.
No, power unit will be watt only, no?
Yes,
Let's
sir.
check it. Okay, so first of all, we should calculate the equivalent resistance. So R2, R3 are in the parallel. So 10 and 10 in parallel will give me how much? Can I write it directly? 5. 10 into 10 by 10 plus 10 है ना? Parallel we get it. R1 R2 by R1 plus R2. So 10 into 10 by 10 plus 10, right? 100 by 25. And that means the resultant of these two is what? The 5. Is this 5, this 10, and this 10? Can I say the R equivalent of this circuit is 10 plus 5 plus 10? So how much is getting? 25. Na? So what will be the current in the circuit? So battery EMF is 100, total resistance 25. So we got the current as 4 ampere. So that means in this question, current from here, how much it will be flowing? 400. So sorry, 4 ampere. है ना? So 4 ampere will flow here. After reaching here, can I say this current is going to distribute in these two branches? And R2 and R3 are equal and they are connected in parallel. So whenever the two resistors are connected in parallel, what happens? Current distribute in those two branches. And how does it distribute? It distribute in the ratio of their resistance. If both the resistance are equal, then current is also going to be equal. So this current is going to be 2 ampere, this current is going to be 2 ampere. And again here current will become what? The 4 ampere. So what is the power developed in R1? The P1 will come. How much the P1 will come? I square into R1. So I square means 4 into 4 and 10. So 16 into 10, 160, we will get it. For R2, how much it will come? So P1, how much it will come? I square into R1. So 160. And unit of power is what? That is what? P2 and P3, can we say that same will come? Because both have same current, both have same resistance, isn't it? If current and resistance is same, then what will happen? Power is going to be same, isn't it? The power is going to be same. That means
Yes,
current is 2 square into 10. So 4 into 10, 40 watt each. Okay, na? Understood? The power consumption calculation, most important thing about the power consumption is what? That we should know how to calculate the current in each branches. Okay. Once we understand to calculate the current in each branches, what will happen? We will be able to calculate what further? After knowing the current in each branches, we can calculate the power consumption. Is it clear? Sometime it will be called power loss. Sometime it will be called the power consumption. Sometime it will be called the power consumption or sometime the power loss. Understood? Now, the next type of question of this power consumption will come. It will come the power consumption in a bulb. Okay. Now, in case of a bulb, what happened? There is an important thing. In the bulb, what is going to be different? Let me discuss. So before that, let's discuss one more example. Okay. Question gave what? Two electric heaters are there. Okay. Okay. Not two electric heater. Let's say one electric heater. One electric heater has two identical coils. You have seen the electric heating rod, isn't it? Electric heater rods are there, na? Two rods are there, three rods are there. Sometime more cold is there. What you will do it? You will switch on both the rod. If that cold is not much, what you will do it only you will switch on one of the uh, rod or switch on one of the rod. है ना? So one electric heater has two rods, or sometimes it will be written as has two coils of equal resistance. Okay, understood the question of what? Equal resistance. Now, question says what? If they are connected in series, means both the coil of that heater are connected in series. It takes T1 time to heat certain amount of water. Heat certain amount of water. Understood? Like let's say a bucket is there. That bucket has 10 liter of water, right? And we want to increase the temperature of the water from 20 degrees Celsius to 40 degrees Celsius. So we will introduce the heater in that one, isn't it? Right? And how the coils of the heater are there? The coils of the heater are connected in what? Series. Understood? And how much time it took to heat heat certain amount of water by certain degree Celsius? T1 time. Okay. Now the question they are asking, if initially they are connected in series, na, both the coils, if instead of a series, if instead of series, coils are parallel, connected in parallel, then how much time it will take? Do you understand the question? Or sometimes they will give you in the question that first time it is taking 10 minutes to heat the water, है ना? 10 liter of water is there, and we want to increase the temperature from, let's say, 10 degrees Celsius to 30 degrees Celsius. It took 15 minutes. If the coils are connected in parallel, then how much time it will take? Something like that. Understood? Then how much time it will take? Understood? Same amount of water, same temperature change we want. Do you understand the question first or not? Please tell me. First, try to understand the question. Once you understand the question, definitely the answer can come. But first of all, tell me, do you understand the question? What is given? Actually, please try this question and tell me how much is the answer coming. Both are having equal resistance. Both are having what? Equal resistance. Okay. What is the heat required to increase the temperature? Can I say that ms delta T, isn't it? If mass of water is m, specific heat capacity is s, and its temperature has been increased by something delta T, then what is the heat needed? Ms delta T. That's actually thermodynamics concept, but that is not needed here. You just need to know that heat should be required. And how the heat will come? Heat will come from the electrical heater. Understood? So please try it and tell me what is the answer coming to us.
So like I think 4 upon T1.
How much? 4 times of T1.
4 divided by T1.
Okay, 4 by T1. 4 by T1 तो not possible. T1 by 4 should come. But time is there na.
Yes, sir, sorry.
So T1 is
T1.
the time. So 4 by T1 तो time unit will not come. Okay.
When
चलिए
4
let's
T1.
see. 4 T1.
Yes, sir.
Okay, let's see. See, electrical heater are there. First case, what you have done? There are two resistance. There are two coils. है ना? Let's draw it like the resistance. So it's like the two resistance and equal given to us are connected in series. And now you are going to connect these two resistor through what? Through a supply voltage, isn't it? Acha, tell me, in the first part of the question and second part of the question, what remains same? Resistance of the coil remains same. And another thing, can I say the voltage will remain same in both the cases? Please tell me, can we say that the voltage will remain same in both the cases? Because when I will use that
Yes.
heater, through the same voltage I will be connecting that heater. Na? Only the internal arrangement of the copper coil has been changed. Understood? So what remains same? So this time I am to apply the V voltage across this. So how much heat it will develop? And in thermodynamics heat transfer, you will learn this concept. Heat required to increase the temperature of any substance by delta T is ms delta T. But actually that is not needed to solve this particular question. Okay. Tell me what I should write it here. Can you tell me which formula I should use it here? I square R, V square by R, or V into I? How much heat is being generated in this circuit? In this circuit, how much heat is generated? Can I say V square divided by 2R? Please tell me. Can I say that heat generated is V square by 2R into T? And how much time I am taking to heat that water? T1 time. Understand the case 1 when the coils were connected in series. Second case. In the second case, what I am going to do it now, these two coils which has the same resistance R, now these two coils are connected how? Parallel, right? But you still have to increase the temperature of what? The same amount of water by same temperature difference. So this time how much heat is needed for you? You still need the same amount of heat, ms delta T. Let's call that heat as H. Now tell me, is it the supply voltage is still V? Because I'm going to connect this heater again to the same circuit, isn't it? The voltage remains same in this one. So should I use it V square divided by, look at that, this R and R combination. Is this R and R combination is the parallel one?
Sir, in series,
How
like,
much it will come? R by 2 will come. Tell me.
sir, in series, like, we can't use V square by 2R, right? Because V is not same in both the resistance, right?
V is not same in both the resistance, but across this combination, how much is the voltage?
Then can you use that?
The V voltage is not applied across R. V voltage is not applied across R. V voltage is applied across the heater. And first case, heater is the combination of two resistors. So the total resistance of the heater will become 2R, and that heater is connected across what? Across the V voltage. Please tell me, understood?
Yes, sir. So can you use that
I square into R.
yes, sir, I square into R, we can use that formula.
Yeah, we can use it. We can use it. Okay, I will solve it by that method also. Don't worry. Okay. But why I am doing V method? Because in both the cases the voltage is same. So it will be easy for me to do the comparison. Okay. And in the second case, what is the RR? So R are connected in parallel. So overall this combination gives me how much resistance? R by 2 resistance. How much time it has taken? T2 time. Now in the case 1 and 2, am I going to generate the same amount of heat? Let's compare it. If I compare it, see that the comparison will become V square by 2R T1 equal to V square R by 2 into T2. V square get cancel out. So am I getting T1 equal to 4T2? What I am getting? T1 equal to 4T2. That means T2 is what? T1 by 4. That means initially if it was taking 20-minute time to heat that water, now it will only take 5-minute time. Understood? Just to understanding purpose, let's do the alternate calculation. Okay. Alternate calculation means what? Can I say that heat requirement is ms delta T? That should be equal to H. Now tell me, how do you want to calculate the heat? You want to calculate I square R? Okay, apply it. So I will write it. Can I write it I square R into 2 times? Can I write it? Please tell me.
Yes, sir.
Please tell me. Because it's a series combination, so both resistor will have same current. How much will be the current in both the resistor? Let's consider something I. So I square R in one resistance, I square R another resistance into 2, right or not? So, and next thing what I will do, I will multiply by the time because it is power written. When I multiply the time, it becomes a heat. Second case. Second case, if I want to calculate heat required, I will write it ms delta T. What you want to use it here? I square R, but I need to be calculated, then both I won't be the same. So here, should I use it? V square by R. See, it's a parallel combination. So voltage will be same na in both the resistor.
Sir, but the current is across the heater, right? Then
Yeah, so heater means what? This entire combination will be called heater na?
yes,
And
sir.
this one will have some current I. Which
I
one will become I1, I by 2, I by 2?
but across the whole combination, the current is I only, right?
Is it the same as the earlier I or different I? Check it. First case, I is equal to V by 2R. Second case, I is equal to V divided by R by 2. Both the current are not same. Check it.
Yes, sir. Yes, sir.
Understood?
Yes, sir.
See, whatever method you apply, you are going to get the same result. Okay? Either you do the calculation for individual resistance and then you get the total power consumption, or you just calculate the power consumption in the equivalent one. We are going to get the same result. Understood? So here V square by R is through one resistance. Should I make it 2 times of that one into T2? If I'm going to compare it, see that here it is I, here it is V. How can I compare it? So either I have to bring I into V or I have to bring V into I. Then only the comparison will be done. We will get my answer. So which one you want to convert it? Can you write this one as I equal to, what is the current in the first case? Is the current in the first case is V by 2R. Please tell me. Is the current in the first case is V by 2R? Please tell me. So V by 2R square into R into 2 into T1. So what I am getting? V square by 2 into 2, 4, right? By 2R T1. Just check it. Is it the same expression? I got it now. V square by 2R into T1. And what we have here? V square or 2V square by R into T2. See that? Is it the second expression is as it is what we have written here? Look at the equation 1 and 2. And then I will compare it. Again, the voltage is common, will get cancelled out. So whatever way you want, you can calculate it, but make sure that what voltage and current you are using in the calculation should not get confused with that one. Understood?
Yes, sir.
Now, sometimes they will give you a question like the bulb or tube light like that. What does it mean by rated power? Rated power, right? When you go to the market and buy a bulb or a tube light, is it written on the bulb that this is a bulb of 10 watt, this is a bulb of 20 watt, 15 watt, 18 watt, like that it is written in the question on the bulb packet, na? Tell me, whenever you are going to market to buy any kind of equipment, not only bulb, anything, right? You go and buy a mixie, right? You will see 750 watt will be written, right? You buy the iron press, it will be written 800 watt, 1000 watt, like that. You buy the electrical heater. Is it written that, okay, this appliance are going to consume 100 watt, 200 watt, or 500 watt? Fan is there. Simple charger, mobile phone charger, right? 20 watt, 40 watt. Nowadays, even 60, 80 watts of the mobile phone chargers are coming, isn't it? So that is called actually the rated power. Okay.
Yes,
What
sir.
we only focus on the power written, right? But there is one more important thing written at that packet. It is written, if you go and buy the bulb, it will be written like this: 20 watt. And it will be also written 220 volt 50 hertz, like that. Meaning is what? If you connect this bulb to a voltage source like this, then it will consume 20 watt. If you connect to something else, then it will not consume the 20 watt. Understood? So this 20 watt is called as what? What is this called as? This is called as the rated power. Understood? Here I have taken the example of alternating current source. Same thing happens in the direct current source also. Okay. So let's try to understand about what is the rated power. So rated power means what? Any instrument, any appliance will consume how much power if it is connected in a circuit as per rated voltage, as per the required voltage. Understood? So what is the rated power? It is power consumed or power received or power transferred to a resistor, or power consumed, let's call it consumed by any electrical electrical by any kind of electrical appliance. When that power consumption will happen? If that appliance is used exactly as per the written voltage, as per the mentioned voltage. Understood? But if you connect it in a circuit where the voltage is not same as it is mentioned, then it will not consume the same power. It will consume maybe more, maybe less. If it consume less, it is safe. But if it consume more than rated power, that appliance will burn out. Then the bulb get fused na sometime when very high voltage is suddenly comes. That is because of what? That the power in the bulb got exceeded the rated power. Okay, it is power consumed by any electrical appliances when it is connected across a designated voltage. Understood? But
Yes.
if you don't connect it across designated voltage, then what will happen? The power consumption won't be same. Depending on how you have connected in the circuit, it may be more than rated power or less than also. If it is less, no problem. It will glow, but not with that much brightness. Okay, if power consumption is less than the rated power, what will happen? The glow of the bulb will be less than the given one. So now see that what will happen. This is how we represent a bulb. Let's say in a bulb it is given to us 50 watt, 200 volt. What does it mean? Tell me, what does it mean? That means if this bulb is connected across a battery of 200 volt, then what will happen? This bulb is going to consume how much power? 50 watt of power. But if the same bulb I connect across only 100 volt, is it still going to consume 50 watt of power? No, it will consume a different power. If I connected it to 300 volt, it will again consume a different power. Understood? So the power consumption through a bulb or any appliance or any heater is different depending on how it is connected in the circuit. But what remains same? Can you tell me what will not change for the bulb or any appliance? However you connect it in the circuit, the resistance of the bulb or any appliance never changes. What changes? Power consumption definitely will change depending on the connection in the circuit. But what will never change? It's a resistance of that element is never going to change. Okay, so whenever you calculate the power consumption in any appliance, before calculating that, always calculate the resistance. Okay, so that is the only important point about this one. What is that? Always always calculate resistance of the bulb, or not only bulb, any appliance. Okay, resistance of the bulb based on the power rating. What is the power rating? This is what I have written now, 50 watt, 200 volt. This is called the power rating. Okay, so based on this power rating, what we will do it, always calculate resistance of the bulb based on the power rating. And what is the important thing? And that is never going to change, never going to change irrespective of the circuit. Whatever circuit you want, you can connect it now. But what will never change? The resistance of the bulb is never going to change. Understood? Please tell me. So now let's discuss an example and try to understand this one. Okay. What is the meaning of this power rating thing? Let's try to understand with the help of an example. Okay. In the question gave, there is one bulb like this. There is another bulb like this. Let's take a simple series question. This bulb is given 50 watt, 200 volt. That is the bulb one given. And this is given to us 50 watt and 100 volt. I am not checking the data. I am directly taking the values. Okay. And I'm going to connect a 200-volt battery here. Internal resistance of the battery given 0. This is the bulb 1. This is the bulb 2. Question asked, find power consumption in the bulb 1 and 2. It may be possible that one of the bulb got fused, right? Sometimes they ask you in the question, which bulb will get fused first? Which bulb is safe if it is connected in these kind of circuit, okay na? So first just solve this question and try to understand the meaning of the power rating. Then we will discuss those questions also, okay? Find power consumption in the bulbs. Okay, chaliye, tell me what is the power consumption in the bulb 1 and bulb 2? Will you say that, sir, 100 watt? Sir, power in bulb 1 is 50 watts. Power in bulb 2 is 50 watt because that is what given? No. Why not? Because bulb 1 will consume power of 50 watt if it is connected across 200 volt. But do we know the voltage across this bulb? How much is that? No, we don't know. What is the voltage across this bulb? We don't know. So if we don't know the voltage, how can I find out the power? Okay, so what I will do it first, I will calculate their resistance. So for bulb 1, what will be resistance? So bulb consume 50 watt power when it is connected to 200 volt. So can I write it power equal to V square by R? So can I say resistance of bulb 1 will come V square 200 square and 50. Please tell me, do you understand? Please tell me, do you understand the
Yes, sir.
power resistance of the? So how much we are getting? It's coming 200 into 200 by 50, right? 50 into 4 and 4 into 200. So bulb 1 has what resistance? 800 ohm. That is never going to change. Yes, power through bulb 1 can change. Can be more than 50, can be less than 50, equal to 50. But resistance of the bulb 1 is in all the cases is exactly 800. Okay, so 50, that is 4. So we got it 800 ohm. Let's do the same thing for the bulb number 2. So for the second bulb, if I write it, what is the power consumption? Second bulb resistance will come V square by R. है ना? V square by, sorry, V square by P. Resistance I am calculating now. V square by P. So I am getting 100 into 100 divided by 50. 200 ohm. Now I can solve this question, isn't it? Please tell me. Meaning is what? That bulb 1 is going to act like 800 ohm resistance. Bulb 2 is going to act like 200 ohm resistance. So if I want to calculate the current in this circuit, if I want to calculate the current, because once I get the current, I will get the power also. The current in the circuit, how much it will become? Net voltage by net resistance. 800 plus 200. So 200 by 1000, 0.2 ampere, we got it. Now tell me, what is the power consumed by bulb? We have to calculate that one. So what I will do it? Will I use it? I squared into resistance of the bulb 1. How much is that coming? Just check it and tell me. 0.2 into 0.2, 0.04, 32 watt coming. Just check it once. And what is going to be the power consumed by the bulb 2 by B2.2 square into 200. So 0.04 and 2. So 8 watt it is coming. Just check the calculation once for me. Check it. Both the bulb are safe. See that both the bulb are safe. None of the bulb is getting fused. They will ask you in the question which bulb will get fused, right? Like those kind of things they will ask you. Okay. So always calculate what is the power consumption. How you will calculate? By first finding the resistance, which is never going to change in the bulb. But power consumption can change. It's a 50-watt bulb. But in this circuit, it will only show me how much power consumption? 32 watt. Second bulb is also 50 watt. But in this circuit, it is only showing it how much? 8 watt. So please tell me, understood what we discussed?
Yes, sir.
Right. So this is about the rated power and power consumption. Next tomorrow class we will have it in the morning, right? So tomorrow we'll discuss about that what is going to happen if uh, some combination of resistance as combination of bulb is given, which bulb will get fused, which one will remain safe, like that we will discuss it. Okay. So morning 9, let's connect it. Okay.
Okay, sir.
Right.
Thank you, sir.
Thank you so much, everyone, and let's connect it tomorrow then. Okay. Take care. Good night.